কেন? ও রাত্রিবেলা। Okay, a very good morning to all of you. I think my voice is audible to everyone. As far I think, I shall first of all give your QR code, and I think as per my videos which I have uploaded in YouTube, I have completed till module two, one part. Okay, so if you follow your syllabus, another part is CRO, complete CRO. I mean, whatever you have learned in your second year, all those basic electronics CRO, that's CRO. Now, should I discuss CRO again? Because I don't think, because CRO, I know you can do it yourself. Okay, I will just provide you the notes of CRO. That's it. So, will you do it yourself, CRO, or I have to teach you again? Then I can move to module 3, because module 3, that part is new to you. But CRO, you know. So, tell me, Ayushi, who are there? Vishakha, so I think Monica, Rajkumar. Batao, you tell me the answer. Am I audible? Hello?
मैम
Yes, ma'am.
Yes, yes, बोलो.
मैम थोड़ा रिपीट कर देते कोई टॉपिक्स तो क्लियर हो जाता.
Repeat CRO? Okay, fine. Then I will discuss CRO today. Okay. ठीक है. Okay, I think you have done with your QR code. Let us move to अच्छा उसके पहले मैं CRO का PPT निकाल लेती हूँ. Stop share. Wait just a second. CRO is easy, na? It's known to you already.
मैम बस थोड़ा रिपीट कर दीजिए.
I'm opening the PPT. Let me share the PPT with you, then we can go with that. Okay. In module 2, the first part was all those generator and all those frequency measurement techniques which we have learned. And the second part is CRO. Okay. So today we will discuss first with CRO. Let us discuss some of the points of CRO. So what is CRO? CRO, I think you are much aware of CRO. You have seen CRO in lab. Okay. CRO, main work of CRO is what? Why we use CRO? Because when we connect any device with CRO, we can see the waveforms. Okay, because एक device हम लगाते हैं, definitely उसका waveform check करने के लिए we need a device. We need a something from which we can see what kind of waveform we are getting. So to view that, we need CRO. What we have done in my time, what I used to do, we don't used to draw the waveform by our free hand. What we used to do from the CRO screen, whatever waveforms are coming, we used to stress that. We have a stressing paper, and we used to stress that waveform. Okay, so that was very much used in my time. When I was doing lab in my higher studies. So what we used to do, whatever with our every instrument, CRO was connected, because there is no other way to visualize your waveform. So what we used to do, we used to keep stressing paper with us. Whatever waveforms come, we used to stress it, and we never used to draw the waveforms with our free hand. Always we used to stress. So stressing paper is there, it's very easy and it looks good also. And we used to then paste it in our copy that this experiment, we got this kind of waveform with through CRO. So CRO definitely, it's a very useful multi-purpose display instrument, okay? And also versatile laboratory instrument that you all know. So what are its functions? First of all, display. Second is measurement. Third is analysis of waveforms and various other phenomena in electrical and electronic circuits. Okay. Now, CRO, you can say it is generally a XY plotter. You see here in my PPT also it's written, it's a XY plotter. So on a single screen, you will see that it's displaying an input signal versus another signal or versus time. Okay. So in a single screen, you will obtain this kind of XY plotter. So, and the next is it can measure amplitude, frequency, phase shift, everything. Now, if you minutely check all the functions of CRO, then it means in the lab you will get to see there are many functions of CRO. Okay, there are many switches, there are many buttons, and they have their own functions. We can shift the waveform from left to right. We can shift the waveform from up to down. We can change the probe. We can do many things with the help of CRO. Okay. Now, second thing is that, yes, again, CRO is susceptible to temperature and pressure. So we have to always keep that in mind. Okay. The second most important thing is this point. See this 1, 2, 3, 4th point, you just look it out. A moving luminous spot over the screen displays the signal. So how we are getting the signal? Definitely a moving luminous spot. This is important. This luminous spot is produced by the beam of electrons striking the fluorescent screen. Okay, if you visualize the CRO, which I will show you, there is a fluorescent screen, and this luminous spot, which they are telling Komal Kumari. Who is this Komal? She is new. Hello. Ayushi, anybody tell me? Those who are in the class? Hello.
No, ma'am.
Who is
Komal is ma'am. Shreya. Shreya, ma'am.
To tell Shreya to change her name. So this kind of names I won't accept in the class. I don't know her. Why will I accept her? Tell her to change the name. Monica, बताओ. बोलो.
ये मैम उसके बहन का ईमेल आईडी, इसलिए नेम वही शो करता है, तो वो चेंज कर लेगी.
हाँ उसको फिर से आ रहा है कोमल कुमारी आई वोंट एडमिट हर टेल हर टू चेंज इट ओके अपनी मेल आईडी से उसको बोलो लॉगिन करने के लिए दैट्स इट okay so luminous spot what I was explaining to you that is definitely produced in the CRO with the help of when the electron beams strike the fluorescent screen. Now CRO used to study waveforms and definitely other time varying phenomena written here from very low to low to high frequency. Now in CRO we have different parts also. Okay, Acha, one more thing, normal form of a CRO uses a horizontal input voltage which we sometimes called as time base. Okay, a word you will find here while learning CRO. It is called time base, which we will discuss. Okay. Now, in CRO, what is important? It's operate on voltages. And definitely CRO, we can convert the current, acceleration, pressure, and various other quantities with the help of transducer, okay, if it's required. Now, CRO, definitely I told you now, in CRO, the main important thing is CRT. So you see here, what is CRT? The CRT is the cathode ray tube. Okay, so cathode ray tube, a cathode ray oscilloscope, it consists of a cathode ray tube, that is CRT, which is the heart of the tube, you can say. Okay, and definitely some additional circuits are also present to operate the CRT. Now, main part of CRT, now we will discuss, Vishakha. Now, let us discuss the main part of CRT. Okay, let me come to, yeah. I think this picture is visible to you clearly. Let me enlarge it. Okay, so can do you remember? I mean, these things I have I already taught the students of second year in some other branches. So do you remember what are the basic? This picture is not so much proper. Wait. Okay, CRT we will discuss with this picture. Okay, now you tell me, any one of you, what are the main parts of CRT? I mean, what are this much I think you should remember, parts of CRT, the which we will discuss. Can you tell me the parts of CRT? Anyone?
Electron gun.
Electron gun, okay, then you can view from on this picture also, which I'm showing to you. Yeah, follow, next.
Beam.
Yes, deflection plates, you can see here, deflection plates are there. Then you can also see fluorescence screen. Yes, fluorescence screen is this one. This portion is the fluorescence screen. These are the, yes, correct. Glass envelope. Okay, glass envelope is another important thing. So the major, electron gun, deflecting system, fluorescence screen, these are very important parts of CRO. Okay, so let me discuss. You just follow this picture and I am explaining one by one. So we are discussing the one by one. What are the parts? First, electron gun assembly. Okay, so where is the electron gun? See, the electron gun mainly comes here. The picture is not shown so properly. So I have this picture right now. So actually here vertical deflection plates, you can see a vertical electrode. Behind vertical deflection plates, you will see here some pre-accelerating anode here. Some pre-accelerating anode or focusing anode, whatever. Okay, it will behind this vertical electrode. It is called pre-accelerating anode. Okay, and also for focusing anode. So this total, I mean pre-accelerating anode plus focusing anode together is called electron gun. Okay, together is electron gun. So electron gun assembly, it produces definitely a very sharp focus beam of electrons, okay, which are accelerated to a very high velocity. Now this focus beam of electrons, they strike this fluorescent screen, okay, and what happened with sufficient energy to cause a luminous spot on the screen. So I was discussing with you about luminous spot also. So how it is created? By this process. Now, after leaving the electron gun, the electron beam then passes through the two pairs of deflection plates. That is, one is vertical deflection plate, second is horizontal deflection plate. You can also call it deflection plates. So voltages applied to this plate deflect the beam. Okay, so voltages applied to one pair of plates move the beam vertically up and down, and voltage applied to other pair of plates, they move the beam horizontal from one side to another. Okay, so these two movements, which we call vertical and horizontal, they are independent of each other. Okay, and thus the position of the beam, it decides the position of the beam anywhere on the screen. The working parts of CRT, you can see it's enclosed in an evacuated glass envelope. So the glass envelope is this one. Okay. Acha, yeah, glass envelope is this one, and so that it emitted electrons which are able to move freely from one end of the tube to the other. Now, electron gun, the source of the focused and accelerated electron beam is the electron gun. So keep this in your mind. What is electron gun? It is a source of focused and accelerated electron beam is the electron gun. So electron gun, what it do? It emits electrons, forms them into a beam, consists of a heater, a cathode, a grid, pre-accelerating anode, focusing anode, and accelerating anode. So all things. Okay, so electron gun is so important. It's very important. Now this next we will move on to. We will not go into details. Okay, electron gun, I'm done. Now let us come to deflection system, which I told you we have two types of deflecting plate, horizontal and vertical. Okay, deflection plates, and they actually decide the position of the beam, whether it will go up and down and whether it will go left to right. So that is also important point, deflection plate. Now, definitely these are pair of plates, means see two plates are there. So these are pair of plates. So the pair of plates, which is called deflection plates for horizontal as well as vertical, and you can see it is the positioning. You can see from the picture the positioning, how it is connected, which actually decides the position of the waveform. Next comes the screen of CRT. At a deflection system. Yeah, now comes to fluorescent screen. In fluorescent screen, what you have, which I told screen of CRT, the screen material of the inner surface of CRT is made up of phosphor. Okay, it's important. So keep in your mind, made up of phosphor. And why phosphor? Definitely because this material absorbs the kinetic energy of the bombarding electrons and re-emits it in the form of a bright spot. So spot of light which is produced on the screen where the electron beam hits. So this is important. Another material is there, that is the electrons were collected and trapped by a aqueous solution of graphite, that is called aquadag. Okay, this is also important material, aquadag, which is connected to the second anode. So this is also important material. Okay. Now next, so 3 parts I have discussed. The time-based generators, this we need to know. What are time-based generators? It come under the CRT Graticule. Okay, before coming into time-based generator, wait. It's here, time-based generator. Follow this picture. This is the overall diagram of a CRO. Okay, over the previous one picture which I showed you, that is only for the CRT. Okay, and this is the overall picture of the CRO. So where you can see that the plates which are connected, suppose with the vertical plate, vertical amplifier is connected. With the horizontal plate, horizontal amplifier is connected. You can see now. Next, you are having a time-based generator. You're having a trigger circuit. Okay, you can see electron gun here. So this is the overall circuit of a CRO. Okay, if you say it's overall circuit of CRO. And you can see here the supply voltages, what we are giving accordingly. It's connected to the CRT. Follow this picture nicely. This picture is important. Basic picture of CRO, you can say. First of all, what is the function of time-based generator? Now, see, most of the CRO applications, they involve measurement or display of a quantity, which varies with respect to time. So, time is a very important here in case of CRO. So, we have used here time-based generator. Now, this requires that CRT spot, which I told you, luminous spot, that move across the screen from left to right with a constant velocity. It's not that sometimes the velocity will increase, sometimes the velocity will come down. It's not that. So it should have a constant velocity, the spot which is moving from the screen, and it is decided by this time based generator. So in order that the beam deflect linearly from left to right, some voltages are applied to the horizontal deflection plates or this thing. Next is the circuit which develop the ramp, this kind of voltages. These are called time-based generators or sweep generators. So time-based generator, other word is also called sweep generators. Okay. So sweep output of the sweep generator is called sweep voltage. So what is the output of sweep generator? It is output of this generator. I'm writing here. Its output is sweep voltage. Okay. So I think this is clear this much. So typical form you can see here where it is connected. It's connected with this vertical amplifier, then trigger circuit, then time-based generator. This is the actual circuit of this time-based generator. The time-based generator is important. Okay. Sweeps, which I told you that sweeps are of again many types. It's so much detailing. So let me check one thing. Let me see the syllabus. Wait. Achha, in your syllabus, what you have seen: introduction, oscilloscope, block diagram, cathode ray tube, delay line, multiple trace, oscilloscope, scope, transducers, oscilloscope technique, digital storage oscilloscope. Okay, fine. Wait, digital for oscilloscope. Let me see where I have that. Okay, one pattern I have discussed with you even in the previous class also, that is important. So that I will tell you, Lissajous pattern. Just a second. Okay, there are some problems also. So we can solve it. Just a second. Achha, why we use amplifier? Amplifier, you know, right? What is why we use amplifier? What is the function of amplifier? Can anyone tell me? What is the function of amplifier? See here, we have connected two amplifiers accordingly with the plates. I mean, with the direction of the plates. One is with the vertical, another is with the horizontal. So, what is the function of the amplifier? Can you tell me, anyone? What? Hello? What is the function of amplifier? Josna, Manorama, Monica? What is the function of amplifier? No response. Hello, my voice is audible. Hello. Hello, Rajkumar. Rajkumar.
Yes, ma'am.
What is the function of amplifier?
Ma'am, it's amplify the signal.
Yes, very good. Where are others? Ayushi is not responding. Aditya is there. Josna is there. Manorama is there. Not responding
Yes,
at
ma'am.
all. Okay, Aditya. Okay.
Yes, ma'am.
Okay. Now I will discuss the electrostatic deflection of this CRO. Okay. See, actually, electrostatic deflection. One figure I'll draw now. You will see two parallel plates with a potential applied between them. These plates are those deflecting plate in CRO that I told you, vertical and the horizontal plate. Okay. Now, those plates produce a uniform electrostatic field in the y direction. So, direction means that I will tell you in the figure. So, any electron entering the field, it will experience the force in the y direction. Y direction means simply if you take any diagram, how we do the coordinates just like this. This is the y direction, this is the x direction. So I am telling you that the plate produce uniform electrostatic field in the y direction, means this direction. Okay, and the electrons entering the field will experience a force also in the y direction, and definitely they will be accelerated in that particular direction. But there is no force either in the x direction, and if you say z direction, that will be here. This one is the z direction, but it's not so much of important here because no acceleration of electrons are in these directions. So if I take a diagram, then I can draw it like this. Wait. Okay. So here I will draw, wait. Just like this here. And here it is a distance d. And this is a screen actually. You just assume there is a CRO screen. Okay. And in this CRO screen, this is a straight position actually. It's not so much slanting. This is a very much straight position. Okay, straight position. And the plates are here. Here is the plates. Okay, so I'm drawing here like this. So these are the deflecting plates. Deflecting plates. Okay, and this deflecting plates actually make an angle of theta here at this position, and up to here at this position, the distance of this deflecting plate is small d. Okay, small d. And here the distance from here to here is L, this one. Okay, and this is the picture. And this is the definitely y and x concept I have told you also. And this position, you can say it's a parabolic position. Parabolic position. Okay. And you can take here as POX, just a notation. So there's a picture of electrostatic deflection. So from this picture, I want to tell you the notations what the notations important here. That is, first notation is EA. EA is the voltage of pre-accelerating anode, which I told you. Voltage of actually this we require in writing a formula. We have a formula here. Accelerating anode. And where is accelerating anode is present? In electron gun, right? Which I told you. Electron gun is a combination of pre-accelerating anode and the focusing anode. Okay. What is E? What is E? Can you tell me? E is what? Hello? What is E? No response. Tani, मैं किसको पढ़ा रही? What is M? Anyone? What is M?
Mass of electron.
Mass of electron. Yes. Mass of electron. And what is the value of mass? That will be kg, unit. Sorry, unit. Okay. What is this VOX which I have written? This is the velocity of electron while entering the deflecting plates. Okay. Velocity of electron while entering the deflecting plates. Okay, it will be meter per second. Okay, then comes ED will be a term that is actually potential. So ED you will write here. I'm writing here. Okay, this is the ED. ED is the potential, you can say potential between the deflecting plates. So I'm going to the not next page. I'm writing here. ED is the potential between the deflecting plates. Deflecting plates. Okay, and you can write it in voltage V. Then D is the distance. Small d, I told you distance between deflecting plate. I'm not writing it here. Acha, LD, another one will be here. LD is this distance. Okay, LD is this distance. L small d. This distance is LD up to here. So this LD is the length of deflecting plate. LD is the length of deflecting plates. Then comes capital L. See capital L, which I have written. This is the capital L. Okay, capital L distance between the screen and the center of the deflecting plate. Okay, so a capital L is the distance between screen and center of deflecting plates. Okay. Next comes D. What is D? D is the deflection of this D is the deflection of electron beam on the screen in y direction. So I'm writing here D is the deflection of electron beam, okay, on screen in which direction? Y direction. Clear? So that will be meter. So L is also in meter. This deflection is also in meter. So one thing is here from this particular diagram. Let's see. From this particular, I'm going to the next page. From this particular diagram, the loss of potential energy when electrons move from cathode to accelerating anode. So I need the loss of potential energy when the electron moves from cathode to accelerating anode. So I can write the potential energy is equal to E, that is the electron charge of electron multiply with EA. EA, what is EA? The voltage of the pre-accelerating anode. So this I can take as equation 1. So the gain in kinetic energy, by an electron, what is it will be? This will be definitely, we know, half mv squared. So here V is VOX, so I will take VOX squared. This is my equation 2. Okay. Next, see, mass of an electron, how much it is? Can anyone tell me the mass of electron? Mass of electron, do you know? What is the value? What is the mass of electron?
Ma'am, 9.1.
Yes, very good, very good. 9.109 we sometimes take into 10 to the power minus 31 kg. Okay, this is the mass of electron. So equating the two energies, that is the kinetic, this is the potential energy and kinetic energy. We will equate these two energies. Equating the two energies, we will get here VOX equal to 2E EA divided by M, that is to the power half. Okay, so this is my equation number 3. So this is the velocity of electron in the x direction. Okay, so this is the what? This is the velocity of electron in x direction. Okay, x direction when it enters the deflection plate. So velocity in the x direction remains the same throughout the passage of electron through the deflecting plate. So from here we can write another thing, that is the field, electric field intensity in y direction. What will be that electric field intensity we take is epsilon. This is the electric field intensity. Okay, we can also write it as ED divided by D. So ED, I told you, potential between the deflecting plates, and small d is the distance, that is the distance between the deflecting plate. So this is important. So this is another equation coming here. So now we have to keep in our mind this equation 4. Second, next point is we have to see what is the force acting here, means what is the force acting on the electron in y direction. So what will be that? So I'm writing here in the next page. So force acting on electron in y direction, okay, it is equals to force F, V you can write, that will be E, electron, epsilon, that I told you the electron of intensity. So we will get here E, ED upon small d. This is my equation number, how much? 5. This is my equation number 5. Next, we can also find out from here the suppose if we take the acceleration, if we consider something the acceleration, then the force we can also write as, means force in other language we can write m into acceleration, like this we can write now. So we can take acceleration, we can find out what f by m, something like this. Okay, so we can write here. So again, FV, we know what is the value. This value we will put here. So it will come something like this. Okay, something epsilon we can write in place of for that. So M. Okay, so this is another formula of finding out the force. Force in 2 terms we know. This is essential while solving problems. If we do any problem, it will be essential. Now, so we can keep it like this. Now, some problems if we try to do, we can do it on basis of this particular formula that we need to find out the force and the acceleration of the electrons while it moving through the screen. So take down a problem. Take down a problem. हाँ बोलो.
Ma'am, force acting on electron in y direction FV is equal to E epsilon कैसे होगा?
E epsilon कैसे होगा? E epsilon y force. See, I am finding out force in 2 ways. One is this, one is this. Any one of the formula you can use. So force acting E epsilon, what is epsilon? Epsilon is the electric field intensity, which I have found out already in my wait. See in the previous page, ये तो epsilon है. What is epsilon? Epsilon is the already it is what? This is ED is what? ED I told you. What is ED? Potential, right? Bolo, what is ED?
Yes, ma'am. Potential between the
Yes.
deflecting
D is
plates.
the distance. So see, this is the epsilon. This electric field intensity.